Hello everyone, it's June 29th. Alright, let's get right into it. What do we have today? Two comments, nothing of concern. Alright, let's take a look. Max consecutive ones. Edition 3. Alright, given a binary array of numbers and an integer k, return the maximum number of consecutive ones in the array if you can flip at most k zeros. Oh, we can flip. So k equals 2. So we can flip 2 zeros into 1. So if I flip this, then the longest subarray is underlined. So 1, 2, 3, 4, 5, 6. Okay. We can count the maximum number of consecutive ones originally. Right? So we have 3, we have 4. And then we can flip 2. So flip these two. Okay, flip these two will be the same. Flip 3. So we can flip 3. So we want to flip the ones that's connecting. So yeah, flip these two. We got 10. Okay. This feels dynamic programming to me. Let's get the example. 1, 1, 1, 0, 0, 0, 1, 1, 1, 1, 0. So each 0 we can either flip or we don't flip, right? And we have k equals 2, so at the most we can flip 2. So basically we can say given the current remaining is 2, right? If we can, so this one we can flip it or we don't flip. If we flip it, right? If we flip it, then ending here, what is the maximum number of consecutive ones? So if I don't flip it, it's going to be so I think we can make a, let me think if this is correct. So we have two conditions. One is we have 2 left, we can flip 1 left or 0, right? So we have 0, 1, and 2. And then the column is going to be their position. So we have 3, 4, 5, 6, 7, 8, 9, 10, 0, 1, 2, 1, 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Right? And then all the ones is going to be, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what we consider is zeros, right? So all the ones, we don't care. We just go down. So 0, 1, 2, 3. So on the 3, position 3, if we do not flip it, then we will have how many consecutive up to now? It's 3 consecutive, so that will be 3. And then next one is 3, next one 3, and then these are nothing. And then we count again, right? We count again, and then position 10 is going to be 4 consecutive. Right, 10 is going to be 4. So that's when we don't flip anything. So we go again. Yeah, if we go again. Now, at position 3, we can choose to flip or we do not flip. So if we do not flip, we look up, it's going to be 3. And we flip, it's going to be 4. So the maximum I can do is 4. And then at position 4, we can choose to flip, not flip. If we do not flip, alright, so we can only flip once, right? So this is the one I can flip once. I flip 1, so we can flip. So the next one, if we do not flip, that's 3. Right? If we can flip once, then it's going to be it's going to be what? Where? It's going to be a zero flip. That's zero flip plus 1. So that's going to be 4. That's going to be 4. And these are nothing. And then this is going to be 5. It's going to be 5. Now I'm going to do 2 flips, right? 2 flips. So again, if I don't flip, if I have 2 flips left, so if I don't flip, then it's going to be the maximum of 0 or 1 flip, right? So 0 or 1 flip. So the maximum of 0 or 1 flip, that's going to be 4. So if I don't flip, it's going to be 4, right? But what do you mean by 2 flips? I mean, I can only flip once. So that means the previous one. But this is the first one, so it doesn't have a previous one. It doesn't have a previous one. So, oh yeah, we have to look into the previous one. The previous 0, right? The previous 0. It do not flip. Then I flip. Hold up. That's not right. These are not 4. 1 means we can allow for 1 flip. So I am the first 0, right? So I can do 1 flip because the previous one is a 1. So I can do 1 flip. I can do 1 flip myself, or I don't flip. If I don't flip, if I do not flip, I look up and I see it's going to be 3. If I flip, then I can do 3 plus 1, so I say it's going to be 4. But the next one, right, I'm talking about this one, next one. If I allow for 1 flip, right, if I allow for 1 flip, I say I want to flip. If I flip, if I don't flip, then the maximum is 3, which means if I don't flip, I look to the maximum in the previous one, right? So actually, these are all 3. It's a 1, it's going to be 2, it's going to be 3, 3, and then 3, and then this is a start, so it's going to be 1 again, 2, 3, and 4. It's the maximum, right? So here it doesn't change. Okay, 1, 2, 3, and then with 4, if I flip, and the previous one is a 1, so if I flip, then it's good. Now I'm at this position. The previous is 0, and I can only have 1 flip, right? I can only have 1 flip. So if I flip, it's going to be the max of me by myself is 1, or if I no, it's a maximum of me if I flip, right? If I flip, yeah, I have to flip, right? This is 1 flip, so I have to flip. So if I flip, then the maximum is going to be 1, and the maximum of this one. But these two cannot. This is 0. So maximum of this 0, we're going to go to a 0 flip, so it's 3. So this is actually going to be 3, right? Whether I flip or not, this is going to be 3. And this one is the same. We're going to go flip, we're going to give me until here. Flip, going to give me 1, right? Oh, but if I flip, how am I going to handle 2 flips? I don't handle 2 flips. Yeah, if I ending here, and I have 2 flips, so this is like 1 flip. What's the maximum I can get doing 1 flip? The maximum I can get doing 1 flip. If I flip here, then that's it. That's the 1 and 3. Yeah, if I flip once, I still get 3 here. But that's different, right? That's different. And if I don't have this, right? If I don't have this 0, flip 1, this should give me 5. Rethink about dynamic programming. Right, so whether I flip or don't flip, right? We just say I have two flips, so I can flip or I don't flip. If I flip the one situation, I need to know the longest that I can be in. So it's not the end, it's the longest stretch that I can be in if I flip. The longest stretch, like do I belong into any longest stretch? So if I don't flip, the longest stretch is actually, there's actually three, wait, one can count as 3, and these longest stretch is counted as 0, and these are counted as 4. The longest stretch. And if I flip, then it's going to be 4. If I flip, I'm going to be 4. If I don't flip, I would say I'm going to do 1 flip. So say flip, 1 flip. If I flip, it's going to be 1. If I don't flip, that's going to be 0. If I flip, that's going to be 5. So I say when I flip, longest stretch. So what longest stretch can be 1? This is going to be 5. This is going to be 5. So I say 2, right? So this we already flip. 2, we have to go to the second one, right? So second one, we know that if I flip, I'm going to be having 1, right? So if I have 2 flip, we can go say the previous one get flip, then I can get 5. If it's the next one get flip, then I can get 6. So the maximum I can get is 6 in this position. And this is the 5 position. So 5 flip, and I need another person flip. 5 flip, I get 5. Another person flip. Nah, I still don't feel like it's the right way to go. So if I read through, we have most 2 flip. Let's think, how can we use recursion to do this? Basically, recursion means I can flip, like I don't flip. If I flip, right, I compute the maximum I have, and then we compute the remaining, right? We compute the remaining. And remaining has 1 flip. Remaining has 1 flip. So if I don't flip, then the remaining has 2 flips, right? Yeah, if I flip, the remaining has 1 flip. If I don't flip, the remaining has 2 flips. And once we compute the result, we want to know the maximum number of consecutive starting from the front, right? Starting from the front in 2 situations. And if I don't flip, right, and then we need to know the maximum overall, right? And the maximum overall, because that's a 0, so we need to know the maximum overall. If I flip, then we don't know the maximum overall and the maximum extending from here, right? Yeah. Okay. So for each one, like for here, for this, I can say that, and then for this one, it's the same. I can say I want to know if I flip right, then I want to know the maximum, and then here. Right? Maybe this is doable, right? So we have indices and the number remaining, right? And all we need to know is just the maximum consecutive ones, right? We want to know the maximum consecutive ones given the condition, and the maximum consecutive ones starting from the front. So just two things, right? Two things. So let's try it. I want to write it out. So we have, once we reach the first 0, we know the current consecutive, which is the current consecutive is assigned to be 3, right? 3. So I can call the remaining, right? The remaining, we can call it k equals 2, right? K equals 2. And we can also call it k equals 1. So remaining k equals 2. So we say the remaining k equals 2, we're going to take the 0. Right, so this means take the 0, and the remaining we can call k equals 2 or k equals 1. Keep going. Take the 0, the remaining 1, 1, 1, 1, 0. We can call k equals 2 and k equals 1. Keep going. And then 1, 1, 1, and then the last one. Now we have the last 0. Right, last 0. Take it out, and the remaining is empty. When it's empty, right, when the remaining is empty, or the remaining is all ones, this is going to return, we can call k equals 2 or k equals 1. It doesn't really matter, right? So it doesn't really matter. So k equals 2 or k equals 1. So when k equals 2, we go in, right? So we call k equals 2. Now we find this, and then k equals 2 or k equals 1. And k equals 2, k equals 1, both going to return 0, right? It's both going to return the maximum is 0, and the maximum is also 0. So both is 0. So come back to 0, and I say I want to know the k equals 2, which means I do not change. So this one can give me 0, or I call it k equals 1, which means I make a change. So I make a change, I have 1, 1 plus 1. So this one will return 1. The maximum is 1, right? Maximum is 1 when, in this case, I say if I don't change, and we're passing k equals 2, and when k equals 2, coming back is 1. The maximum is 1. The maximum is 1, and the consecutive is also 1. Right, so that's k equals 2. So coming back, if it's k equals 2, that means k equals 2 will give us 1. Now if k equals 1, oh no, it's not 1, because this actually, when I pass into it, this is 4. Right, this is 4. So if k equals 2, which means I don't flip, then I will return 4. That's when the maximum is 4. Right? And before 4, or if I change, then I'll be returned 5, 5. So this level, we're passing k equals 2, will give us give us 5, 5, because we want a maximum, right? So we want a maximum, so this one will give us 5, 5. Now, is this the maximum? Yeah, whichever can make me better, right? Whichever can make me better. So it's going to be 5, 5, which is take k equals 1. Hold on. K equals 2 will return, this one will return 4, right? Remaining, or k equals 1, that's also return 0, so I return 5. So this is when I don't want, like I do not want to take anything, then the remaining will give me 5. If I want to take something, then k equals 1. So this one is k equals 1, right? And if k equals 1, I can take k equals 1, or I can, oh, and k equals is, wait, hold on. K is the number that you can flip, right? So the number of can flip is 1, or the number flip is, it can be 0. Because I can only flip 1, right? So it's actually going to be this k equals 1 can flip, k equals 0, and k equals 1 we already calculated. K equals 1 will give us 5, and then k equals 0 will give us, or don't flip, will give us 4. So this one come back and be 5, also 5. So 5, 5, 5, 5. So in the first case, k equals 2, which I don't turn 0, give us 5. The second case, k equals 1, which means I turn to 1. So this one actually going to give us 6. So this return is going to be 6 and 6, right? So this one will return 6 and 6 to this level. So in this level, this one k equals 2 will give us 6 and 6, right? And k equals 1, well, we don't know what's going to give us. If k equals 1, then this one can do 1. Alright, this one do 1, and 1 will give us, only 5. That's one will give us 5. 5 and 0 actually, so it's 5. So 6, 6 would be better. Yeah, maybe this one will work. Give it a shot. 29. Yeah, I'm gonna do recursion first. I think recursion will be easier to reason, and if it works, then we can try to write it into a bottom-up solution. So this is going to be a top-down solution. Well, it sounds like I have solved it. I actually don't know if I've solved it. So here's what we're going to do. All right. What are we going to do? We're going to accumulate. Right? We're going to accumulate. So the def helper. Right? Helper, we're going to have the index of the 0. Right? Index of the 0. And let's think. Index of the 0. What else do I need? Index of the 0. A k, the remaining, right? The remain flippable, right? Remaining flippable. That's about it, right? and then this one going to return a tuple of int and int. Right, tuple of int. So we'll probably need to say tuple here as well. Okay. So basically it's this index, right? We say if what happens when it's 1? And say while nums index is equal to 1, we say nums index plus equal the previous one plus equal nums index minus 1 if index is larger or equal to 0, larger to 0, or 0. Right? So we accumulate the ones and then index plus equal 1. So that's that. That means if we encounter a 1, we just increment until we hit one that's not 1, that's a 0. Right? So we hit a 0. Now index is pointing to a 0 with the flippable. Now in that case, we have two things to do, right? So we say we're going to do either I flip or I do not flip. That depends on the flippable. So we say if flippable is larger than 0, then we can do helper index plus 1, next one, and a flippable minus 1, right? So we can do the next one. This one will give us max from start and max overall, right? Give me this. If flippable is larger than 0. If flippable is not larger than 0, then we can only do 1. That says I do not flip. I do not flip myself. So there's another option is this is flip. So max overall, this is flip. Max overall if I flip, right? And then we have the same call. So this one is no flip. What we call no, right? No flip. If I do not flip, then I'll go to the next one and I'll call flippable. Okay, so now we have these two situations counted for. And now once we counted for these two situations, we need to see which one is the best, right? Which one is the best? To see which one is the best, we're going to say actually, I think we can call, let's do this max from start and max overall, both is 0, right? We don't, actually max from start and max overall is from this one moving on. Hold on, do we count? Yeah, we do have to count max from the start. Now max from the start and max overall is going to be nums index minus 1. Right? This is also nums index minus 1. This is so far we have. Right? And so far is what we have. And what if it's the starting point? Then it's 0, right? And it's 0. So let me say equals this. If index is larger than 0, else 0. Yeah, let's just do this, right? And then we say max overall is equal to max from start. Okay, and then if it's larger than 0, we're going to say flip, overall flip equals this, right? And then we can compute. We say max from start. Well, this is I flip, right? Flippable. So if I flip, then max from start should be equal to maximum max from start plus 1, because I flip, and plus max from start flip, and max overall shall equal to max max overall for sure, the ones we have so far, and max from start we just do, and the max overall flip. So it's going to be 3, so I have to put them in this, right? So that's flip. Or if we don't flip, right? If we don't flip, then max from start equal to max. Well, max. If I don't flip, then I am 0. So max from start does not change, right? Does not change. Yeah, max from start does not change. But max overall, we can do max overall equals max. Of course, max overall and max from start and max overall flip. Yeah, max overall flip. Because these two, yeah, so that this one we don't have to consider again. If this one is maximum is this, so we just need to consider this. And max overall and max from start, they might change over here, so we have to include both of them. So that's that. And then we return max from start and max overall. Right? So that's this, and we definitely have say from functools import LRU cache. So this one we're gonna cache it. Cache max size equals none. So cache this. When do we stop? We say if index is equal to length nums, right? Then we're gonna return 0, 0. So that's the end condition. So what we're gonna do is we're gonna say helper index is 0, flippable is k, right? And then what do we return? Well, this one has maximum start and rest max overall, so we're gonna return rest. Okay, let's take a look. Okay, so first one, k equals 2. Wrong. Yep. Second one, this. Okay, k equals 3. Okay, and this is going to be nums k. This is going to be longest ones nums k. Alright, give it a shot. Syntax error. Oh, it's not. Oh, it's else. Not enough value to unpack. Oh, I forgot to put the answer in. 6. This is 10. Local variable referenced before assignment. Where? Which variable? Max overall flip. Oh, there's no max overall flip. This is max overall no. Yeah, it's max overall no. No flip. Yeah, because I already done this. Int object is not iterable. Oh my god, I have so many issues. Max from start equals max from plus max from start. Oh, this is not a max. Yeah, it's not a max. It's just max from start. If I flip, then be 1. So I think this is actually plus equal to 1 plus max from this, and max overall is going to be max from start, and max overall, and this. And then here, no overall, okay. And again, list index out of range. How is list index out of range? 0 equal 1. Ah, I see how it's out of range. Okay, and now the first one we fail. That's fine. Let's see, how is out of range? Well, it's out of range because we have to do index is smaller. Alright, let's put n here. N equals len nums. So this one equals n. And this has this smaller than n. And oh, still out of range. How? How is still out of range? Index plus 1, then it shall get out. That's weird. Max from start equals. So this one is out of range. Well, this is smaller than n, and then equals 1, and it equals this, plus 1. Now I index is n, and max from start index is n. So I think we probably should do this one. So we run this first, and then check it here. There we go. Okay, so we have wrong answers. Let's take a look. First one. 11. How is it possible 11? There are only 10, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 11. But how is k is... I didn't actually set any requirement for k. Well, we have flippable is larger than 0. Then we do this. And then when flippable is 0, then... Alright, let's check on index. Let's check on nums. Let's check on nums, index, and flippable. Let's see if any... Yeah, the flippable is never exceeding. So 1, 2, 3, 1, 2, 3, 4. That's what I expect, right? Okay, so what do we do now? Turn. think what we can do is blah blah blah. We're gonna check here, right? Check here. So I'm gonna print index a max from start and a max overall, right? And each index shall go only once. Actually, I also want to print on num as well. So print nums and print a separator. So we are looking at index 10, and we say maximum start is 4, maximum overall. That's correct. Now the next index is 0, 1, 2, 3, 4, 5. Is 5 is this one, right? Is this one. And we say maximum start is 0, and max overall is 4. Bless you. That's actually not correct. Oh no, this one is not correct. This is 10. Max from start. Max from start should be 5. This should be 5. Let's see. So index is 10 coming in and nothing. So this one will give us 4. This one will give us 4. Flippable, it could be 2, right? And index flippable maximum start. Index flippable is 0. Oh yeah, this is flippable is 0. Flippable is 1. Flippable is 2. It's 5, 5. Ah, that makes more sense. But then we have this 11. Where does this 11 come from? I have 9 or 8. And why did we call this one again? 10, 0, 4. We already done that. Isn't 10, 0 already done it? Why would I call it again? That's interesting. We have 10, 0, 4, 4. We get called it 2 times. 5, 0, 0, 4. And then we call 10, 0, 4, 4 again. I thought we already cached it. 9, 0, 3, 4. 10, 1, 5, 5. So for 10, flippable is 1. Yeah, so we flip it, that's a 5, 5. Oh, we have 9. Wait. Why will we have index 9? That's not right. Index shall never be in this position. Okay, why would index be 9? Well, index smaller than n, and it's 1, we'll just keep going, right? And then index always plus 1. And when we return, how does index end up at 9? That doesn't make any sense, because we already done this. If index coming in to 10, and then immediately go to 5, right? Well, how do you go to 10 again? Shouldn't you go to 4? Flippable, index plus 1. Then I call, yeah, because this is the first, flippable is larger than 0. Then we do flippable -1. And then we do this. Okay, hold on. So we go 0, 1, 2, 3. So we start from 3, right? I feel like too complicated. I want a simpler case. It's too long. Let's do. Let's just do. Don't do so many. Right, and then also don't do so many here. I want to keep the same number of zeros. Right, this one shall give us 3. Right, this one should give us 3. Yeah, 3 actually pass. But oh no, that's not the purpose. The purpose is to examine. So 0, 1, 2, 3, 4, 5. 5, 0, and then 3. Go to 5 again. Go to 3. And then go to 2, go to 1. Yeah, that's how I expect. Let's take away a 1. Now this one shall be 1, 2, 3, 4, 5. This one should be 5. Man, this one also pass. Simple cases all pass. Complicated case do not pass. No, that's not due at the end. The end is hard to reason. Let's call it at the beginning, so we kind of see how things are called. Right? So I do it here. So every time we know where we are. Oh, we don't have max. That's fine. It's I just want to see the order of calling. Right, so we have first call 0 and 2. Right? So 0 and 2. Yeah. Second call after them do so 0, 1, 2, 0, 1, 2, 3. So now we're at 3. Right? Because the input, that's why it's encountered twice. Because this first coming in should be 3. How do we handle this situation? I mean, we can go through the original, just get all the values out, and get all the 0 indices out. And then we can avoid this situation. Okay, let's do that. So we're gonna say I in range 1 to n, right? Say nums if nums I equals 1, right? Then nums I nums I equals 1, nums I plus equal to nums I plus I minus 1, right? We can do that, increment, and if it's not, then we don't do anything. So, and also we're gonna do a 0 indices. Else 0 indices dot pan I, right? So we can, let's get nums and 0 indices out. Yep, So that's the one. And then this index is going to be 0 indices index. Right? This index is going to be 0 indices index. So we go 0 and k. That's still the same. But we don't have to do this. I'm going to say indices equals len. Len what? Len 0 indices. Then we'll return this. Otherwise, from start, going to be let's call it zi, so you don't have to type as much. Zi, right? Let's also say m equals len zi. So that's going to be m. And we say max from start equals zi index minus 1. Right? Index minus 1. So it's the, well, it's actually not. It's zi this minus 1. If zi index is larger than 0. Right? Flippable, and this is index plus 1. So we want to go to the next 0. Right? The next is 0. And blah 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 blah, and return this. Okay. Now we pass. Now we pass. Let's try this one. Right now we pass both. Now I have a little bit more confidence. So let's copy this. Put it in here. Let's just run it. Let's see if we got lucky. Judging. Ooh, no, I think we have a wrong answer. Yep, we have a wrong answer. Alright, it's fine. Take a look. This is our wrong answer. Okay. What do we have? We have expected 4. That's true. Okay, expected 4. Again, we can just print out. So after this, let's see. So we're gonna print nums and zi just to make sure. Oh, we're missing. Zi is missing. Ah. Should be from n. If it was 1, then should plus this. If I is larger than 0, else is 0. Oh, now we got 3. Get closer. Get closer. Hold on. I'll be back. All right, I'm back. All right, let's keep debugging this problem. All right, let's see what happened. 0, 1, 2, so we go 0. Max overall. Okay, I think we can probably print, let's say, index flippable. So 0, 4, 1, 3, 2, 3. That's fine. Let's go here. I want to print index flippable and what? Max from start and max overall. Kind of observe. So we say 0, 1, 2. Flippable is 1. Oh, hold on. Index. Index is this index. We have to do zi index. So zi index will be 2. Right. Flippable is 2. Max from the start is 1. Yeah, let's not print zi. It's kind of polluting my eye. Oh. Hold on, this does not feel right. Zi. Oh, I did not count the last one, I think. So if index equals to m, I should not return 0, 0. I shall return. No, I shall return. Ooh, this is a good question. What should I return? I shall go to the. Basically, go to the end, right? So this is going to be. It depends. We're going to say if zi, if zi minus 1, right? If zi minus 1 is equal to m minus 1, so the last one is 0, then return 0, 0. Else, we're going to return nums minus 1, nums minus 1. Yeah, because that's the total number that we can get. Oh, come on, man. Syntax is wrong. Alright, try this one. This one pass. Okay. Now we're going to try everything else, and we remove the print. I'll have another print. Okay, all these pass. Try it again. Try it again, and let's just remove this, and also remove this. Okay, submit, pending, judging. Ew, I think we have issued again. Oh, a time limit. Time limit. Oh wow, we have time limit problem. So this is correct, but we have time limit problem. Ah, yes, I see. Because k is this. This is okn, which is basically on squared. But this is correct. So this is correct, but this TLE. How do we make it faster? How do we make it faster? I think maybe And this is ON, that's fine. Is this part now already cached, but it's not sufficient. Right? It's not sufficient. I mean, there's one thing we can do is if the remaining number or we can count total number of zeros. Maybe the total count number of zeros is smaller than. We can add a line. We say it's like analyzing, right? We say if total number of m, right, this is the total number of zeros, is smaller or equal to, we can flip, then we can return n. Let's see if that's the trick in order to pass. Let's use this custom case. Not sure. And nope. That's, I mean, that is a trick we can include. But that's not the case. How many are we talking about? Let's print n k. Turn 0. And I just want to see m and k. Oh, that's not right. Okay. I mean, dynamic program. This is dynamic programming, but it's not working. Can we use like greedy to solve this? I mean, basically we have patches, right? We have patches separated by zeros. And the best strategy will be trying to merge as many patches as possible. Okay. We try to merge patches. What if we just count, right? What if we have a count of zeros and count of ones? So we have count of zeros. So that's 2 zeros, so we're going to solve 0 and a 1, right? So we have 2 zeros, 2 ones, 2 zeros, 3 ones, 1 0, 2 1, 3 0, and 4 ones, right? I'm looking at this example. So we can do this, and then we say the total k is 3, right? K is 3. So when the k is 3, it is the best that we are trying to merge, right? We're trying to merge these ones. So we have all these ones, right? So the best we can merge is we want to merge everyone. So we want to see if we have, but we don't have k as much. So we can say we can merge this, right? That will give us this sum, 2 plus 3 plus 4, that'll give us 10. Or we can merge this, 2 plus 2 plus 3 plus 1 plus 2, that's 10 as well. Or we can say we want to merge this, but that's 4, so we can only do 1. Hold a minute, hold a sec. Maybe we can do this. So we have Well, start with 2. We can take 2, 2, 1, right? Or we take 1, 2, 2, or we take 0, 2, 2, 3, 1, right? Or we take, so here we say we take 2, right? And then we say we take 1, and then 3, 1, 2, 1, right? And then we say we take 0, because that is the best. Hold on. So we have one position. So we have this 2, this 3, this 2, this 4, right? And the maximum values is 2, 2, 1, 3. And the best strategy will be trying to merge. So yeah, like if we swap the zeros at two different ends, like at two different, it's not connected, right? If we combine them together, and one of them say is big, then it will always be bigger if we combine them together. So the best strategy is always to combine the zeros that are right next to each other. By right next to each other, I mean like these two zeros and these two zeros combined together. So we can do like a sliding window to solve this, right? So we say start, we can say we have 2 of this and 1 of here, right? So we have say 2 here, 1 here, we'll compute what's the value, and then we say we're gonna take 1 out. Oh, but then there are a different situation. We can do 1, 1, 1. Oh no, we have to fill in every single one, because otherwise you're leaving gaps, and we don't want gaps, because merge them together is always better than having them. Yeah, merge them together is always going to be better than having them separate. So we start 1, right? That's fine because we don't merge them. But then we can take 1 here, then we can take 2 here, right? Then we do this, and then we say, okay, well 0 here, and then we 2 here, and then we take 1 here. So we merge them, and then we can take 1 here, 1 here, and a 1 here, right? That's 3. Because 2, 1, that's already... No, we cannot take 1. Hold on. Again. So in between, we want to merge them, right? In between, we want to merge. Because if we do not merge the ones, again, like if we do not merge the one, we just split them out, and then we get whatever value. It will always be better that we take all the resources into the gap, so we can get them together. So as I say, yeah, it is greedy. Yeah, it is greedy. Let's just say it is possible, like we can achieve the maximum without merging, right? Without merging, then it is wasted, right? If we don't merge, and we say this is the maximum, and it will always be better to merge. So yeah, so it's always better to merge. So let's just say we're going to take the positions in between so that we can merge. So we say we're going to take 2, right? So we can take 2 here, and if we take 2 here, we have 1 left. Then we kind of see if we can merge. So we look left, look right can merge. So we merge on the right. That gives us a result, right? And then next one, we take. So yeah, that's it. That's the first situation. We'll take 2, and then we choose to merge. And the second situation will be we have 1, and we have 2 on the left. We already done. So we're looking left. We already Done. So we only look right. Only look to the right. So look to the right. That's 3. It's not merging, but we can still do it. Yeah, yeah. So we first do 2. We try to merge it, but we cannot merge. If we cannot merge, we just pull in everything in it, right? And then they give us a result. And then the next one we have, then we can merge. Do we look to the left? So we always look to the left, or we always look to the right? Hmm. Because if we merge, so whatever we look, if we only look to the right and try to fill up everything that we can, right, then we get a value. Right? We fill up what we can, and we can get a value out. And then we go to the next one, and then we can merge it. But we should look to the left or look to the right. If it can merge on the right, if it can merge on the right, it will always better than not merging. Yeah, merging will always better than not merging because all the zeros flipped, that will always be added. Like no matter what, all the zeros flipped, that will always be added. And the additional benefit is through merging. So I think we can just go from the center. Right? We go from the center and we look to the right. And we try to fill up everything that we can fill up. If we run out, then we fill up onto the left. So 2, 1, right? That's solution. And then we look at 1. We're trying to look to the left, go to the right, and we can fill up 2, right? And then that's actually giving us 8. And then the last, we fill up 3. Here, that gives us 10, and that's it. So at each position, we try to fill it up, right? We fill it up, and if there's leftover, we throw to the right. We always throw to the right. If we can fill it up, we throw to the right. Fill it up, we throw to the right. And if you throw to the right to fill it up, and then we keep throwing to the right, and then if it's too much, then we wrap around, we throw to the front. Right? If it's too much, if there's leftover, if there's leftover, then we just add the leftover, because we already merged everything. Right? We already merged everything. So we fill this, and then we fill the next one. If we can fill every single thing, and there's leftover we cannot fill, then we just add it. If we can, we just fill it. We just keep filling to the right. Keep filling to the right. Keep filling to the right, including the first one. Try to fill it up. Try to fill it. Fill. Cannot fill, and then we fill up here. Trying to keep filling to the right. Let's try this idea. So this is DP. I think this is a TLE DP solution. Apparently this is ON squared. That's why it's not working. ONK. That's why it's not working. Second solution will be. Second solution. I think this is greedy. Second solution. I can call it greedy. Right? So this one goes like this. Goes like this. Something I want to do it here. So we're going to say zeros and ones. right? Zeros and ones. And maybe I should, I don't know. So basically it's a count, right? It's a count how many ones, how many zeros. I think Python has a function to do this. Let's say itertools. I think itertools has something. Not 100% sure, but I think accumulate, compress. I think it's compress. Which one am I thinking about? Filter, product, permutation. No, I think it's group by, right? Where's group by? Python group by? It has group by. No, pandas has group by. itertools group. Yeah, itertools has group by, right? itertools dot group by. Yeah, it has group by. Okay, let's go back to itertools. I didn't see group by. Oh, it's right here. All right, group by. It says make an iterator returns consecutive keys in groups of interval. A key is a function computing a key value for each element. If not specified, key defaults to identity function. Okay, so list G. So basically we can say for K is what? K is the key, G. So all we need to do is get a, but we don't know which one is 0, which one is 1. I think that's fine. We can handle that. So we can say the counts, right? Counts equals, I probably have to go from import itertools, right? So counts equals itertools dot group by nums, and for I don't care about the key, so for this group in this, and what we care about is the len group. So that's the count. All right, let's try the first one. See if this is what we're looking for. So print counts. Object group with the tool group by has no len. What? I have to go list this. Alright, so that's 3, 3, 4, 1. Okay, so we know. Now we're gonna iterate through the zeros, right? The zeros. And we say if nums 0 is a 0, then index equals 0. This index can be in counts. If first is 0, else it's going to be 1, right? And then what we're going to do, just iterate through and say while index is smaller than what? Index is smaller, so we have to go for the last index. It depends, right? If we start with 0, then we're going to end up here. If we start with 1, we're going to end up here. So we're going to say while 0 index plus 2, right? Plus 2 is smaller than len counts. All right, so over here, plus 2 is hold on. This plus 2 going to be here, this plus 2, so this plus 1 plus 2 is smaller or equal to. I think it's smaller or equal to. Right? So index is here, plus 2, smaller or equal to, so we shall do this. If index is here, plus 2, nah. No, that is while true, and then we go even, and we're gonna check this at the end. Let's go while true, right? While true. So we're coming in, right? And then we say, what do we say? What do we say? We say no, I think just index smaller than len counts shall suffice. Yeah, shall suffice. So we say rest is 0 if counts, right? No, it's while counts. While counts. So temp equals 0, right? Temp equals 0 if index is equals to 0, right? Else temp equals counts 0, right? So we're gonna say counts index, right? If counts index is smaller, right? If counts index so keep adding to the end. Keep adding to the end. If counts index is smaller than k, okay, temp is the total, and then this is flipped equals, every time we go flipped equal to 0, right? So we just say if flipped is smaller than k, right? If flipped is smaller than k, then we say flipped. How do we say this? If flipped is currently, no, not flipped, is flippable. Flippable equals k. So flippable equals k. And we say while flippable is larger than 0, right? Well, flippable is larger than 0, then what we're going to do is temp gonna plus equal to the maximum I can flip. So it's gonna be actually gonna be minimum of flippable and counts index, right? So this is the maximum I can flip right now. Right, after that, we're gonna check. I'm gonna go flippable. Right, flippable. Hold on. So we're gonna say flipped equals minimum of this. right? The minimum of the two, and then temp always add flipped, and this one is going to be minus equal to flipped, right? And then while flippable is larger than 0, right? Then we can, that means after we flipped, we go to the next one, the flippable is, we still have flippable remains, which means we can check it here, right? So we do this, and we say if flippable, right? If we have flippable, if we still have, if flippable is larger or equal to 0, which means, hold on. No. We're gonna say flipped, right? I'm gonna say if flipped is equal to counts index, right? That means we flipped everything here, so we can concat with the next one, right? So we can concat. So we say we flip this, we can concat with the next one. So we say temp plus equal to counts index plus 1 if index is smaller or equal to len counts minus 2, right? If it's smaller than counts minus 2. If it's not, then there's no more next. So else is going to be 0. Right, temp gonna, so say we flipped the entire thing, so we can concat everything, and then we go back up, right? We go back up. Otherwise, then flippable will be 0. Then we're gonna exit. Right? So we're gonna do this until flippable reduces to 0. Right? So we always add flipped, and then try to add a next. Oh, and also index plus equal to 2. Right, so index and the plus equal to 2. And I'm going to count index plus 1, right? And then hold on. Count index, and then index plus equal to 2, and I'll come back to the start. I'll have to do the whole thing again. And come back to the start and do all the things. I feel like we can do better. Isn't this just a sliding window, right? Out the front, and then hold on. How do we think about this in sliding window terms? So we have the total number. So we have current index. So the left is here, right? Left, and right is here. So if we go, if left, we can fill, or we fill as much as we can, right? We fill as much as we can, and then if we have leftover, then we go to the next one, right? We'll go to the next one, and if we're leftover, we'll go to the next one. So we extend from the start to as most to the right as possible, right? Once you do that, and we say, okay, we're done. Right, we're done. On the left, so we're always trying to fill the entire thing. So we fill the entire thing on the left, and then we extend all the way to the right. And then we say, okay, we're done. We remove this, and then we try to put on the right. Now keep extending. Right? I think that would be a better solution, right? So the index. So we have an index start, but I think it would be better if we go a left and right. So we say left, is this, right equals left. So initially these two are the same, right? And then on the right is actually the rest going to be 0 here. So we're going to do the first extension is going to be right going to extend to the end. Right, so we say while right is smaller than len counts. Right? And now we left and right is the same position. And then we say flipped equal to the minimum of these two. Right? And after that, then if there's no more flippable left, then we, if no more flippable left, so, and the rest is going to be 0, right? If nums 0, if left is 0. It depends, right? If we're going to say like how much is on that. If is 0, if left is 0, else it's going to be counts 0. Alright, so we go inside. Alright, we're going inside, and we try to see how much we can fit, and we can fit more. We keep moving right down until we cannot fit anymore. But what if we cannot fit? Like, which side do we attach to? Okay, the first gap is huge. If the first gap is huge, I mean, we can attach on this side, right? And then we're moving on to the next side, right? And then once we're done, we move on. So we can attach on both sides, right? We're going to attach on both sides. So basically, attach on this side. And then, once we're done, we'll remove from here. And basically, when we remove, we're removing both, right? When we remove both. And then, this is the whole amount. We're going to put in here. And I'm going to put in here. I'm going to put in this position, right? And then that can be attaching to the left. Then we attach to the left. And if it fails, we keep going. If it doesn't fail, that's fine. Doesn't fail, and then we go move again. Attach. Eventually, gonna attach everything to the left. If once we're done, and it still doesn't know that we attach to the right, and then we move. Then we repeat. Okay, how do we code this? Right. And how do I implement this? Right and left to the front, right? So we're gonna do. So we always try to attach to the left first, right? So we're gonna say flipped equals the minimum of the counts left, right? Minimum from counts left and k, right? The minimum of So if counts is big, then we can only flip k. If counts is small, then we can do this. So this is the flipped, right? Shouldn't we? I think we have to do flippable equals k. And then this is going to be flippable, right? So the flipped is the minimum of these two, right? So this is every single time we want to flip. So after we flip, right? After we flip, and we're going to attach these to the left. So we say what? We say counts left. That's the number of zeros in that position. And the flippable is currently flipped. And then if counts left is huge, that's going to be flippable, right? Counts left. So we're going to say compare to flipped and a flippable, right? If flipped is flippable. And I say flippable minus equal to flipped, right? And I say while flippable is still more flippable, we can say flipped equal to, so I think I can say while flippable, while flippable, flipped equals main right, right? And flippable. While flippable and right smaller than len counts, right, and keep going. Minimum this, flippable equals this, right? And then right if flippable, right plus equal to 2, else gonna break. So we don't have to check, we just have to check this. Right? So basically we say the right gonna keep going on. So we flip, if they're still flippable, then right move 2 positions, go to the next 0 and try to flip. If not, then we get out. Now once we get out, because initially we have the attachment to the left. We always attach the left first, which also means we need a rest, right? We need a rest. And every time, if flippable, right? If flippable, then rest plus equal to, so we fill in the flipped, right? So we counted the left already. So if it's flippable, if there's still flip left, then we add the next one, right? Rest and plus equal to the next one, which is counts right plus 1 if right is smaller than len counts minus 1. Yeah, it's smaller than len counts minus 1. Right, if it's smaller than len counts minus 1, else then there's no right, then it's a 0, right? So if it's flippable, we still have, if flippable is larger equal to 0, larger equal to 0, then we can flip everything. Oh no, it's not flippable the larger equal to 0. It's flipped. If flipped, is equal to count, right? If flipped is equal to the count, then we do that, right? Then we do that. And now we do need flipped here, right? So if the flipped is the same number as the counts, then res plus equal to, of course we're going to plus flipped and plus the counts, right? So flipped and the counts, and the right move on. Else, if flipped is not equal to the counts, which means flipped is smaller than the counts, then we just add flipped, right? We just add flipped, which means we're going to add flipped anyway, which means we don't have to add it here, right? We don't have to add it here. We can just say, there's no break here, so we just say res plus equal to flipped. We can always add flipped. We're going to add the next one, and we'll add a flip, and go to the next one, going back up. If there's still flip, now we keep doing, right? If there's no more flip, that flip becomes 0, then we will get out. So when we get out, either we reach the end, right, or we shouldn't call it res, right? We should call it the window. Let's call it window, right? Because it's a sliding window. So res is going to be window, and res is going to be 0, right? So we go through that. Once this is done, right? Once we have a window, and the window is always going to be attaching to the left, right? Always going to be attaching to the left, and this is when flipped, when flippable is reduced to 0, or flippable have no more left. So yeah, we don't have any more 0 to flip, so we don't have to add flippable. So now it's just windows plus flipped. That's the total that we have flipped in this window, right? Once we're done, right, once we're done, we're gonna say res, right, equal to max res and a window. We'll update res, and then what? And then we need to, have the left. How do we know how many is on the left? We don't know how many is on the left. So we need to reduce the number on the left. How do we reduce the number on the left? So right coming in, we already filled it, and we start going. We move the left forward, and we give more to flippable, right? And then we go through this again. So think so every time we flipped and then come out, right? Res equals this. Then if it's not completely flipped, what happens if it's not completely flipped? and minus this plus this. Alright, minus this plus this. Eventually they will end up together. I think this is the situation. So if left and right is the same, right? If left and right were the same, so I say if left and right is in the same position, that means we did not move. We stuck in the same position. Right? We stuck in the same position. Then what? Count. If we count start with 0, and we count start with 1. I have to consider two different situations. I don't like that. That's fine. At the start, so we just say left and right is the same. We're now attaching to the left, right? So we're attaching to the left. And then we say we're going to attach to the right. How do we attach to the right? Yeah, how do we attach to the right? So we attach to the right. We attach to the right by starting from right again, but we're going to say counts right. We're going to reduce counts right. We can reduce counts right to flippable, right? Reduce counts right to flippable, and then keep going. Yeah, if it's too big, that's how we're going to do, right? So if left equals right, that means move this point here. If left equals right, that means we can do counts. Go back up. Right, go back up. And change the flippable value. Right, change the flippable value. Coming in again. And then the right will go on. Yeah, we say counts right equals what? Counts right. If left and the right end in the same position, right? That means it's like this. So when I say counts right equal, so we say all the flip, everything is held inside one position. So we just change counts right to k, right? Counts right change to k, and I'm going to say flippable is also equal to k. Else, right, flippable also equal to k. Now we go back up. We go back up and do it again. And then we can move forward, right? If left equals right, if left is not equal to right, so the left is lagging behind, which means we can take the entire left. Right? We take the entire left. In that case, we're going to say, yeah, I think it will be better counts is this, and then we say if nums 0 is 0, then counts I'll add a dummy. Equals 0 plus counts. So we add a dummy, and then left will always be 1. Always start at 1. Right equals left. A window will always be counts 0. Right, window will always count 0. Result is 0. Flippable is k. And then we can start. Right, when you start, and then this, blah blah blah. If left equals right, counts cut. Counts right cut to the k, and then flippable to the k. And we can start doing. Now we just attach to the right. Otherwise we take everything from the left, we give it to flippable. Right. So I'm gonna say, oh, how does the window change then? In this case, window does not change at all. In this case, we do this, right, flippable, basically we start over, trying to fit into right. So window shall, yeah, this case, I think window shall be 0, because we're redoing it, right, we're redoing, so we fit everybody here, and we cannot fit no more. No, we still have room left. So just like we reset. This is basically a reset. Right, because there's a reset. And if left is not equal to right, then we take everything from the left, right? Which means window and then minus equal to counts left, so take everything this, and plus counts left minus 1, so we take everything, because we don't have those anymore, so take those, and flippable plus equal to counts left, we increment the flippable, right, and then we go back, right, then we go back, and how about left? Well, left, move this, so left gonna go to left plus equal to 2. So left gonna move 2 steps forward as well. That's when these are not the same. And then when we get out, going back, so keep going until we return res. Alright, let's try this one. If num 0 is equal to 0, flipped reference before. Well, flip, no, that's not flip, that's flippable. Alright, this one pass. Let's try these two. Okay, this one does not pass. So we can take a look at what problem we have. So first of all, we're going to print counts. So we start with 0, so we're going to be 2, 2, 2, 3, 1, 2, 3, 4, 1, 3, 4, right? So what we have is 0, 2, 2, 2, 3, 1, 2, 3, 4. So this is 0, is ones, right? And my result is 8, supposed to be 10. So let's see. Left is going to be 1. So I'm going to start from 0, 1, 2, 3, 4, 5, 6, 7, 8. Right, so we're going to start from 1. Window equals count 0. Count 0 is 0. Window currently is 0. That's a 0. Flippable is k. Now right is equal to 1 as well. And then we say, while flippable, yeah, we have k. And the right smaller, yeah. So flipped equals minimum count right. So flippable is what? Flippable is 3. Right? Flippable is 3. So flippable is 3. Start with 3. So minimum counts right, minimum is 2. So flip is 2. So flippable become 1. Right? Flippable become 1. And if flipped equals, yeah, it equals. So window gonna plus equal to counts right plus 1. We can also actually avoid the, that's fine. So right plus 1, if right is smaller than minus 1. Yeah. L0. So window gonna be, window starts with 0, so window now is 2, right? Window now is 2 because we add 2, right? And a right coming here, right coming to here, and a window plus equal to counts right plus 1, yeah, counts 2, and then window plus equal to flip, so 4, right? 4. We actually have 4. Now the window is 4. Window is 4, and then flipped. So flip has 1, so we can keep going. Next one, counts right is 3, flip is 1, so we only have 1. Flippable reduced to 0. It's not, so equal plus 1, so it's 5. So now the first round we get us 5. And the rest is going to equal to 5. Alright, so first one we get to the window is 5, which is right. So we have 2, 2, 1, right? That's 5. And then when we come out, left is here. So left is here. So left is not equal to right. So window, we're going to minus. Oh, I think we minus too much. Oh no, hold on. We minus count left minus 2. That gives 3. Plus left minus 1 is 0. So its windows becomes 3. And flippable becomes 2. So flippable now becomes 2. And the left plus 1 plus 2, so left comes here. Now back up here. Alright. Back up here. Flippable is 2. Right is good. So we're gonna do minimum counts. Oh, that's not count right anymore. Because we already have one. That's the problem. We already have one here. Because we have 3. Position is 3, right? Position is 3. We already have one here. How do we know how many we have there already? We know how many we have by I don't want to change the value. Yeah, so we have the total we do need to have flipped. Flipped. Yes, flipped. Flipped. So we need to have flipped. 0. Flipped. This is the last one, right? Last one. So flipped shall equal to what? Const right minus flipped, right? So we already flipped. The minus flipped, that's the one we need to fit flippable, right? And then the minimum of the 2. Hold on. That's not right. Flipped is the currently, how many is flipped? How many is flipped? No. That doesn't feel right. Doesn't feel right. We have flippable, right? Current flippable. And then we have this is the opening space, right? The opening space. So it should be already flipped, right? We call it already flipped. Call it already flipped is going to be 0. So with a minus already flipped and this is current flipped. So flippable is this. If flipped plus already flipped equals to counts, right? Then we go on and then we reset already flipped to 0. Otherwise, Windows plus this and already flipped equals flipped, right? Already flipped equals flipped. And then we do all this. Let's try again. Oh, it now become 14. That's not right, huh? And this idea of already flipped is important, right? So Windows plus flipped, and then we see already flipped in this cell. Already flipped equals flipped, right? And then do this, come here, Windows minus, and a flippable, and a plus counts. And then when we go back up, come and right, I've already flipped, right? So we go flipped. So flippable is this, and we say this is the amount flipped. Flipped plus already flipped equals this. Yeah, and window plus equal to. Did we add flip twice? Yeah, I think I added something twice. Windows plus flipped. And then we're gonna move. Oh, that's just complicated. It's too complicated. Windows plus flipped, right? We add to the next one, and then if it's not, just Windows plus flipped. And then we remove the previous one, and then, right? So window minus equals previous one, right? And minus the previous one, and we actually need to also minus the already flipped. Yeah, I think we should add already flipped as well. Add already flipped, and then flippable equals this, and plus already flipped. So basically we say we're gonna flip again. So we have a new one, we're gonna try to flip again. 2, and then flippable, we try to fit everything, we try to fit there again. And we say then counts right, we don't have to minus this, we're just going to do counts right again. And flippable minus equal to, and then after this, already flipped also, we're going to do 0, right? If left equals to right, counts right, shrink it, flippable equals this, then already flipped back to 0. In this case, I think we can just put this one inside this before we start. Already flipped is always 0. Try this. Oh, still not right. Alright, so we have already flipped is 0, right? And then we say, well, flippable, and then right smaller than, say flipped equals this, right? And then if flipped, I don't think we need already flipped, right? If flipped, flipped equals this, then already flipped is 0. A window plus equal to flipped, and already flipped equals this. Now I don't think we need this, because there's no already flipped here. We just need after every single time, already flipped is the current already flipped equals flipped. Go back up, flip equals again, blah blah blah, and already flipped. So that already flipped represents the ones already flipped, right? And if left equals right, which means they're in the same position, and we already have that value, so we're going to shrink the counts. So shrink the counts to k, flipple back to k, and then reset window, right? Otherwise, then window gonna minus counts left, and counts left minus 1, and the already flipped, right? Already flipped, and then flippable gonna be counts left and already flipped, left move forward, and then everything we're gonna go back into the right again, and then that's gonna be a left affinity, right? And then we try to see if this one still not, right, flip still not equal to, and then we're gonna do the window, now plus flipped, try this, still not right. Alright, I have to go take a look. So after everything, let's print left, right, window. Okay, left, right, window. Okay, that's what we have. So first round, left is 1, left is 1, right is 3, and the answer is 5. That's correct. Right, that's correct. Second round, left is 3. Left is 3. Right is 7. Holy moly, how did your right get to 7? This is not right. Because we only have 3. No, that's not right. So after the first round is correct, and left is not equal to right, window gonna minus, counts left, windows minus 5 minus 2, windows gonna be 3. And already flipped. Let's also do a window and already flipped. So already flipped is 1. That's correct. We already flipped 1. And coming back up, window shall be 5 minus 2 minus 1. Window shall be 2. Yes, window shall be 2. Window is 2. I think. Window is 2. Let's do this. Let's print both at the beginning and then at the end. So at the beginning and at the end, then we're going to print a separator, right? So at the beginning, we say we have 3, 3, yeah. Window is 2, already flip is 0, right? Flippable. We'll also need to say flippable. Already flipped and flippable. And here is the same. Flippable. Already flippable is 3, so next one flippable is 3, which is true. Flippable is 3, and then we're coming in. If flippable, flipped equals min counts right. Right is 3, 0, 1, 2, 3. 0, 1, 2, 3. Counts 3. 3 we have 2, right? I have 2. Oh, it's right, it's 10. It's 10. Oh, I see this 2. So when I go this, this. So right goes to 7. Right goes to 7. Count is 10. Count is 10 because we have 2 plus 2, 4, 7, 10. Right flipped. Right goes to 7. Should right go to 7? Right go to 7 and say the last flipped is 1. That's not correct. Okay, so we start both at 3, right? Start both at 3. So left to right, both at 3. And then we have window. Window is 2. And already flipped is 0. And flippable is 3. Right? That is correct. And then we're coming in. We say flippable. Yeah, is 3. And the right is smaller, that's correct. So flipped equals minimum. So flipped is 2. We have 2. Flipped is 2. And a flippable is flippable is 1. Right? Flippable is 1. And flippable flipped is 2 is equal to. So Windows and a plus equal to the next one. So plus equal to 3. And the right goes on to 5. So right is now at 5. Window is also plus equal to flipped. That's correct. Already flipped equals flip. Already flipped is 2. So going back up, flippable is 1. And the right is good. Flippable equals to minimum, so it's 1. Flippable is 0. Right? Flippable is 0. And flipped is 1 equals this. So Windows. So now yes, flipped equals this. Now goes here. Oh, that's the problem. That's the problem. So already flipped, I say it's 1, but actually not 1. Already flipped should be 0. Already flipped. If I go to, right, so flipped equals this, then I go to the next one, right? I go to the next one. When I go to the next one, right, plus equal to 2, already flipped is 0, right? Already flipped is 0. And then I think it should be this, window plus equal to flipped. If this already flipped is this, else already flipped equals flipped. This should be 0. Alright, because we go here, already flipped is 0. Otherwise, already flipped is the current flipped. Do this, now we pass. Okay, now we're going to comment out all the print. And let's try the other things. Oh, they all pass. Alright, why do we have so many print? I'm going to comment out all the prints. Reorganize a little bit. So left is 1. Let's say left, right, 1, 1. Windows is this. Windows rest gonna be this. And then flipped equal to K. Now we start. Okay, let's try this solution. I mean, we have a timeout, so we can actually have a good way to test. So we can just test this thing. Let's see. Oh, and I got it. All right, let's try submit, pending, judging. Eesh. I think it's the wrong answer. Take that long for wrong answer? Time limit exceeded. What? Forever loop. I think I hit a forever loop. Edge case, forever loop. Alright, why would it be forever loop? This one will come as 2, 3, 2. 2, 3, 2. Two, three, two. Yep. Why would we hit a forever loop? 2, 3, 2 went to 0, right? So it can be 2 is 0, 1, 0. 2, 3, 2 when the left to right start here. And K is 0. Oh, K is 0. Lord, K is 0. If K is 0, oh, then this one never done. I never do this. And this is going to be this. And, oh, I think we can do while left is smaller equal to right, and I think that one shall help. Instead of giving, let's do this, I think this one shall help. No, no, it did not help. Because left equal to right and flippable is K is 0 going back up. No, it's constantly not helping. Flippable is 1, at least I can do something, right? I mean, I already shrink. I shrink counts to 0, right? I shrink counts to 0. So counts to 0. All right, let's just, I think it's necessary. Just say if k is 0, return 0. No. K is 0 shall be returned. I hope I can. Come on. K is 0. Flippable not doing anything. So res equals counts 0. And then they're the same. So we say reduce counts to 0. Flippable is 0, coming back up. It's all 0. Nothing is flipped. Nothing is flipped. So we shall move forward. Right? The window. Hold on. So what we're saying is we have a current window, right? And then just nothing. We cannot add anything to it. If we cannot add anything to it, and already shrink it down, what we're expecting is to have something so we can do. But if we don't, flippable window becomes 0. Because this is what we say there is here, right? Here. Then counts right equals k. Flip equals k. Window. Window shall not be 0, actually. I think window is not 0. They're in the same position, right? They're in the same position, which means everything we throw in here is not working. Right? So we say we're gonna shrink it. It is 0. It is 0. Windows is 0. We shrink it and try to go to the next one, which means while flippable, flipped equals this. What if we don't do this, right? We allow flippable as 0 coming in. And this will be 0, we will be 0, this will be equal, then we can add the next one, right? We add the next one, and the right can move forward with 0. But if it's not, this is when we break, right? Let's try this. So we have 0, 0, 1, 1, 1, 0, 0, and 0, and should be 3. Yep. I think I didn't change anything. I just I changed something. Yep. Let's try it again. Submit. Pending. Judging. Wrong answer. We have a wrong answer. How many did we pass? 47 out of 48. We're getting close. We're getting close. I think this solution is promising. We're getting close, but still not there. It's back at 25. Okay, don't worry. We'll get it. We'll get it. and we got 24. All right, let's take a look. Where do we get wrong? Again, after this, print counts. All right, this is the counts. Right, and hard to do this. Come on. Okay, we can debug it. So, all the ones, zeros, 1, 3, 2, 1, 3, 2, 2, 2, 6. Alright, this is not gonna work. 1, 3, 2, 2, 2, 6, 4. 1, 1, 6. And then 1, 1, 1. 4 1s. 1, 1, 1, 1. 2, 2, 1, 2. So the start is 1. So ones. End as 1. The rest is zeros. Okay, and then we have indices. 0, 1, 2, 3, 4, 5, 6, 8, 13, 14, 15, 16, 17, 18, and 19 numbers in altogether. Okay, so now we're gonna do starting again. Same thing. So let's say, so the start gonna be left, right, current window, and flippable. At the end, as they're done, right, we're gonna print left, right, window, flippable, and already flipped. And after this, print the separator. All right. Oh, I think we see we have flippable at the end. Ah, that's the one. You see that? That's the one. So I think all we need to do is max window, that's the window, and we have the remaining flippable. And the flippable usually is 0. Yeah, so I think it's just window plus flippable to handle the situation where at the end, right, and then we still have more, but hold on, is that correct? We add 19, right, left, right, is at 19. Hold up. Don't make too quick a judgment. So the start is 7 and 11. So one is 7, the other is at 11. 7 and 11. And 7 and 11 we have Windows 13. Flippable is 6. We have 6 to flip. So we go bara, 6 to flip. So we flipped ba, that's 3, that's 4, and end up here, right? So 13 plus everything. Flippable becomes 1. So this means we flipped 5. I don't see we flip 5. How do we flip 5? Where's 7? Right? Where's 7? And we're at 11. 7, 11. Oh, because we at 11 and right at 11 we didn't flip anything. Yeah, we didn't flip anything at 11, and we have 13 in total, which is true. We have 13 total, and we're gonna flip. So that's 1. That's 2, 3, 4, 5. Right? We flipped 5. Now, here is the question. After we flip 5, we still have flippable left, right? We still have flippable left. Now the question is, if there's more to the left that I can flip. Yeah, we're talking about wrapping around. This is wrapping around. Yeah, this is the wrapping around case. So, which means we still have flippable left. And what we need to know is the left, right? Left is here. Left minus 1 already incorporated. But left minus 2, right? If left minus 2 is larger than 0, if left minus 2 is larger than 0, then we should add the flippable. Yes, yes. Flipped. It's this. Back up. Flip equals this. Yeah. So we're gonna say window plus flippable if, right, if left minus 2 is larger than 0, else 0. So if left minus 2 is larger than 0, that means we still have more zeros to the left of left, and we can add flippable. Which I think, but I don't want to mess around with the window. So this one will pass. So I don't want to mess around with the window. So we just, when we do the result, we add this. Yeah, comment out all this. Let's check. No, it's not right. Other things is not right. Why would it not be right? Window plus, I think we need a parentheses. There we go, now we're right. Okay, alright, last shot. I think we can get this one. Greedy solution. The implementation takes, oh my god, it takes a long time to implement. And then, you know what? I think once we check the answer is going to be like, what, 4 lines, 5 lines. Yeah, now we got accepted. I don't even know the runtime. It depends. No, worst case runtime is ON. Worst case is ON. So this is a sliding greedy solution with sliding window implementation. The greedy idea is like this. It is always better to fill in each 0 gap and concatenate the ones considering each stretch of ones as island and the zeros as gaps. The best strategy is to fill in the gaps, fill in each gap such that the islands can be joined. So the islands can be joined. We can prove this by assuming a solution where max islands is achieved with some zeros. How should I express this? You can prove this by assuming a solution where some gap, right? Let's say where some gap is not completely flipped, while we still can. In this case, any max islands can be further extended by flipping the zeros on its edge, right? Any max islands can be further extended by flipping the zeros on the edge. Therefore, the optimal strategy is to always concatenate islands as much as we can. Thus, we use a sliding window idea. We turn nums into counts of zeros and ones. We try to fill in and try to flip, right, all the zeros. We try to flip all the zeros going to the right, all the zeros going to the right as much as we can, right? Once we cannot go any further, we record current result. Then we remove on the left. We remove the flippable on the left and give it to the right. So continue this until the entire list is covered. Yeah, the implementation is very convoluted. Yeah, the implementation itself is very convoluted. I don't like it at all. There must be a better one, better solution. But the runtime is ON, where N is the length of the list. Here, I have to write some comments. Right, so say flip as many as we can, then grow sliding window from the flipped zeros. Current gap completely filled, right? Completely filled. So we can add the next one, move on. And this is current gap cannot be filled. Note that we can include flippable in the window if there are we'll actually say min flippable. Oh, hold on. Oh, this is actually complicated. Oh, no. It's not. It's not. If we can fill it, then we already consider that situation. The only reason is we cannot, because every time we try to fill it, yeah, so, yeah, it's flippable. Yeah, that's correct. You can include flippable in the window if we are at the end, if we have exhausted, right? We have exhausted the list, but there is still I exhaust the list, and there are zeros to the left of left for us to place the extra flippable. Right, to this, then this is if the gap is too big for the current flippable. If the gap is bigger, right? If the gap is bigger than k, we shrink the gap to k. And this is a sliding window. We move from left and add to the right. All right, let's check the solution. Oh wow, I got very good runtime on this. We got 548 milliseconds, or a 95% ranking. Oh, spent 2 hours and 50 minutes to get to 95% ranking. All right, it's worth it. All right, let's take a look at the solution. Gotta be like 2 lines, 3 lines. I can't even imagine. This gotta be a difficult question. Come on. I should not be struggled. So, oh no, it's not a difficult. It's an easy one. Oh, that's an easy one. It's a medium one. 1004. Yeah, it's a medium one is hit and miss. Right? Sometimes medium one is easy. This one is ridiculously hard for me. It's a medium one. All right, let's see. Sliding window. Look at that. All right, let's take a look. Actually ask is define window of max size with number of zeros, no more than k. Yes, okay. That was good. That's one sentence trying to explain. I used like 2 paragraphs, and there's a one sentence to summarize my 2 paragraphs of ideas. Sliding window approach. The window and the zeros is number of zeros in the window. Ah, yeah, that is the one. That is the right way to think about it. So we go here until we hit the maximum number of windows. Oh man, this is easy. Ah, I see. I think I can code it. Oh, wow. Yeah. I think I can code it without even looking at it. All right, let's try it. Ah, yeah, this is easy. This is a simple question. It's not an easy one, but it's not hard. Yes, that is a hint. The number of, we want to stretch with the number of zeros smaller or equal to k, right? So we have left, right, we're going to start with 0, and result, and the window. Result, window. Everything starts with 0, right? Now we say while right is smaller than len nums. Then we say right, keep going, right? Say while. Oh, we need a count of 0. Oh, so zeros. So we say while zeros is smaller than k, right? 0 smaller than k, then if right, if nums right is equal to 0, then 0 is supposed to equal to 1. Otherwise, don't do anything, then right plus equal to 1. So right, keep moving to the right until we hit, once we hit number of zeros, then we do res equals max res right minus left plus 1, right? Oh, actually, no. Should be smaller or equal to. So it could be 0, I can keep going, right? Until one time, right, or 0 plus 1, or not, then explode. Now we explode. If we explode, once we explode, we come back. Right is here, so we're just going to be right minus left, right? Right minus left. And then we're going to shrink. All right, we're going to shrink. We're just going to shrink all the ones. All right, so we're going to have this, then what? And then we're going to shrink, coming back up. The 0 is still we shrink until the first, so we're going to say while nums left is equal to 1, left plus equal to 1. Once we get out, I'm going to say, I'm going to shrink a 0, right? So I'm going to say left plus equal to 1, shrink a 0, that's shrink a 0. And after the 0 is shrinked, then zeros plus 1, right? Okay, where should the right be? Right should be on the next position. The 0 should minus 1. Zeros. zeros minus 1. Right, so this is zeros minus 1. So keep going until we have fit all k zeros. And then we get it for a max. And then we cut with all the ones. And then shrink zeros one by one. Right, shrink of 1, 0 goes back, comes up, 0 will be equal to k. And we check if it is 0, 0 plus. And right, move on, and then boom, explode. So we do this again, and then we keep shrinking, and then the result in return res. Let's see if solution 3 pass. Ooh, we have a list out of range. Because we say while 0 smaller than k, while right smaller than len, nonce, and 0 smaller than this. Oh, we got one more. Almost there. So, right. And 0 smaller equal to k, so case 2. Right, so it'll be 1, 2, right will be here. Right? Then 0, 1, 2, 3, 4, 5. 5 minus left. 5 minus left is 5. And 5 of this. That's good. Right? And then if left equals 1, left equals here. Right? Then we say we're going to shrink 1. So left pointing here. So 0 coming back to 2. Right? Coming back up. 0 smaller than 2. And right is 0, so 0 plus 1 is 3, and right comes here, so right is here now, left is here, and then coming back, hold on, where should the right be to make it easy to think about? Res is going to be, so right should be, let's just say right is here, right? Right is here, which means, let's say smaller, okay, right? And then if it's 0, and then plus 1, right? And then right plus 1, and back up. So, and then we go to 1, 0 plus 1, 0, 1, and then 1. Right, and next 1, and then we equal 0 plus 1, 0 to 2, and then right plus 1 comes here. And then, oh, jump out. So 0 is equals to k, and right is pointing here. And the max is still this. Maybe this one will be, yeah, this one's right. I think it's just smaller than k. Oh yeah, now left. So left has to be smaller than this as well. That is correct. Okay, let's also do n equals len num. So this n, and then while left smaller than n, and how is this possible? And it's not right. How? 3. So yeah, let's check this one. Same thing. Print left, right, and rest. Yeah, I can print rest. So at the beginning, 0, 0, 0. After one round, actually no. I don't want to print here. I want to print here. Not before. So after one round, 0, 1, 2, 3, 4, 5. Right is here, right? So that's correct, as the first round is going to be 5. Then I shrink it, 1. Right? And then we say 2, 3, 4, 5, 6. Oh, I do this because I want to keep it going. And that's why I do smaller equal to k. Now I see why I do smaller equal to k. So I want to keep it going. 0, 1, 2, 3, 4, 5. But then I will move on to 6. That's not ideal. So if 0 is k, I want to keep going until we hit another 0. So I'm going to say if none_right equals 0 and 0 is smaller than k, then we do this. Huh? Wait. What happened? Right, well, right smaller than n and then 0 is smaller equal to k. I say if none_right is 0, then 0 plus 1 equal to 0. Oh no, this is not right. If then 0 plus 1, right, and then we say if it's 0, because this is not what we want. 0, 1, 2, 3, 4, 5. I want it to stay at 5, right? I want it to stay at 5 instead of 6. But now it's 3, right? Then none_right equals 0. Then say 0 plus equal to 1. I think we just change the break condition. 0 plus 1. If this is 0, and we already fulfill the number of zeros, then we break. Right? So if I don't do here, so if equals to 0, right? I say if zeros are already equal to k, then we break. Otherwise, we keep going. Let this one pass. How about this one? So pass. Oh, now we all pass. Shrink 0 1 by 1. Shrink 1 0, then we add 1 0, And it's possible that here we can add 1 0, because 0 is always shrink. Then we plus, and then we can keep adding right, keep adding right. So we're gonna do this. Submission. Submit. Let's see. Yep, it's on pass as well. So this is much simpler, much simpler implementation, courtesy of this. The idea is the same as solution 2, but expressed in a much nicer way. Our goal is to find a subarray of nums, the longest subarray. Find the longest subarray of nums such that there are at most k zeros. Such that there are k zeros. There are k zeros in the subarray. And this can be resolved using sliding window. Alright, let's see this one. While and zeros plus this nums and equals 0 small equal to k. If zeros plus numbers and equals 0, if number is 0, so plus 1 is smaller, then we plus equal to this, and plus equal to 1, answer equals to max, blah blah blah, until we plus this smaller equal to k, we cannot do, right? And then we shrink the front, zeros minus beginning equals to 0. If the beginning equals to 0, we can do this. If it's not, beginning always moving forward. So at each step, if we can extend to the right, we keep extending to the right. If we cannot extend to the right, we shrink. This is much better. This is good, very good solution. Well, that's it. This is not a good implementation. This is a better implementation. I think this is the ideal of sliding window. It's just you go to the right as much as you can. If you cannot, and then you start from the left. Sliding window. All right, that's it. We spent 3 hours and 10 minutes on a question that's at medium level. Jeez, unbelievable. All right, I'll see you guys tomorrow. Adios.